I'd like to welcome you all to Engine Yard. Ben behind us there is the guy working for Engine Yard. We're here for a special February Node.js meetup, the topic of which is brewing beer with JavaScript powered electronics, which is awesome. For any of you that don't have a beer in your hands, as long as you're not a teetotaler, I'd encourage you to try some beer. There's like we actually ordered in a bunch of Metal Man tonight. So there's the official beer of Node.js, we like to call it. There's a brewery that's started down in Waterford called Metal Man Brewery, and they started doing cans of their beer, producing them about a month ago. So we actually got them shipped up, especially for the event. We have two talks tonight. Two people that have flown long distances to come to Dublin and talk here, both of which are passionate about brewing and passionate about electronics. The first speaker is Peter Marton?
Yes.
Marton.
Perfect, thanks.
Peter, I can't say it. I can barely speak English, that's what I pronounce other things. So Peter has come all the way from homebrew, Budapest, to be here to talk about all the crazy brewing stuff that he's doing, and I think the guys from the company as well, as a group, doing stuff with.
Yeah, they are helping.
Yeah. Give it up for Peter.
Okay, hello everyone. I'm Peter Marton from Budapest, and first of all, thanks for having me here. Okay, that's where it is.
Will you answer that please, Julian? Just press the button there. No? Yeah.
Okay, so thanks for having me here, especially for near form. Today I'm going to talk about Brewfactory, which is a full-stack semi-automated brewing machine. But who am I? I work for RisingStack. We are doing some Node.js development. My Twitter handle is /Peter. You can reach me via email, and you can read some technical and non-technical articles from me at the blog risingstack.com. What is Brewfactory? I mentioned it's a semi-automated brewing machine. It's my hobby project, and it's an open source project as well. So every model in the Brewfactory is open source, and you can find it on GitHub. Before I start to talk about the technical details, I would like to give you a short intro about how to brew beer and why it makes sense to automate it. I will talk about the brewing beer method, which means brew in a bag. This means that you do every processes of the beer brewing in the same keg. It makes it easier. So how to start? First of all, we need a keg. This is our keg. This is a commercial one keg. You can find it at every pub. Only difference is that we cut the top of this keg, put two heating elements and a temperature sensor. So when you have a keg, you add some water and malted barley, and you start heating your mash and what temperature levels, because you would like to extract some fermentable sugars from the malted barley via enzymes. Each of the enzymes work with the highest efficiency on different temperature levels. This is why it makes sense to automate it, because if you can see, it takes hours. And you know alcohol came from sugar during the fermentation, so we need this. And after this process, we boil our malted sugar solution and we add some hops. Boiling is important because we would like to prevent our beer from the infections, so we conserve it. And adding the hops, this adds the fruity flavors and bitterness to our beer. So if you brew IPA, for example, then you will add lots of hops to this, to your beer. And after that, we cool it down because when we add the yeast for the fermentation, the yeast dies at higher temperature, so we have to cool it down. And after that, we put the mash into the plastic bag and add some yeast. After weeks and months, it really depends what kind of beers do you brew. You can bottle it. And we add some sugar or honey for the second fermentation because we would like to produce some carbonation. When you are homebrewing, this is the only way to add some carbonation to your beer. And after that, if we didn't fuck it, then you can enjoy it. And is it hard to brew beer? Yes, it is when you don't automate it. Because let me tell about something this. When we brew beer the very first time, we did it with a gas heater. You can imagine when you do it outside the gas heater and you have to control temperature with that, yeah, it's really pain in the ass. But if you automate it, then this process is the best in the beer brewing because you don't have to do anything. Yeah, but yes, we automated this temperature level stuff. But I would like to mention that the bottling and other phases are still hard and takes time. And what's on the technology side? We had Brewfactory. There is JavaScript everywhere because nowadays you can do everything with JavaScript. Even the hardware part, you can write your database queries, you can write your front end, even the mobile client in JavaScript. Couple of years earlier, you had to know lots of languages and technologies to do this. So I think it's pretty cool that today you can do all of this with one language. And why Node.js is perfect for this? It's because the community and because it's extremely moderated, you have all the power of the NPM packages. So you can build your stuff from that. And yes, Node is good for performance as well. And how to start? If you would like to start with IoT and Node.js, I would like to recommend you Johnify, which is some people like to call it the jQuery of the IoT. It's a Node.js framework, and as you can see, it's pretty easy to control a servo motor on handle a button click with Johnify. Yeah, so I really recommend it to use the first time. But what's behind our system? I already mentioned the keg. From the developer point of view, there are only three things, what is really important for us. We have two heating elements there. It's 4 kilowatt. We have a temperature sensor, a digital one, and we have relays. With the relays, we can turn off and on the heating elements. And if we do this with the right frequency, we can control the power of the heating elements. It's called PWM. To set the value of the PWM, we also need a circular controlling algorithm that continuously reads the temperature sensor and calculates the output from that. This is called PID. We are using that. The PWM and the PID comes with some embedded hardware out of the box, but we would like to have some remote controlling and collect some data to the database as well, so we really need an IoT device here. The first IoT device, what we use, the Brewfactory, was a Raspberry Pi. If you are not familiar with Raspberry, it's a credit card sized microcomputer. It has some ports like USB, Ethernet. It doesn't have built-in Wi-Fi, but you can extend it with a USB stick, for example. Because it's really a computer and runs Linux, you can program it in several languages. For example, Python, Node.js, Java, it really depends on you. But Raspberry doesn't really fit for us, and it's not because of the quality of the product. Okay, let me tell you a story. Imagine it's Saturday, the whole team is together and you are brewing a great new IPA with some special hops. And a power outage happens. It can, because we are using lots of power for the heating elements. And the SD card of the Raspberry gets corrupted. So we cannot continue the brewing. And actually all the ingredients are already in the water. So when it happens and the second time, we decided to drop Raspberry and we move to the SparkCore. It's Arduino compatible in the device. Maybe you heard yesterday the announcement that they start to build a cellular data device. It's pretty interesting. Anyway, it is a built-in Wi-Fi and you can program it in C++. But why is it really important? Because it comes with the Sparks Cloud. It's an open source cloud implemented in Node.js, and with that you can iterate with your hardware with REST API and servers and events. And because it's open source, you can deploy your own one production quality service. I think it's pretty impressive. And this is the current architecture of the Brewfactory, what we do. And it's still not enough modularized. And let's see components. The first one, this is the keg, I already mentioned it. The second one, this is the Spark device, the IoT device. It has a lightweight C++ connector which communicates with the Spark's IoT cloud. With number 5, this is the Brew core, this is the Node.js application, which one deployed to Heroku currently. And it provides some interface for the client, for the Blue UI, which is an isomorphic web client. It's responsive as well. And with number 7, we already have a native iOS client. And we collect some data from external MongoDB. Brewcore, I mentioned it's implemented in Node.js. It uses Goa, the EPC6 frameworks with generators. It communicates WebSockets with the client, actually. So this is why it is pretty easy to implement in Node, for example, and it communicates with the Spark cloud. It's open source, as I mentioned, as every model in the Brewfactory.
Sorry, what's the Spark? What is the Spark cloud? Is that from Spark?
Spark cloud?
Yeah.
Yeah. This is what came out of the box with Spark's IoT device. So it's their service. So if you don't have to build a backend for your application because you can use that one. And for example, reading a pin or reading the data from IoT device or set the pin, you can do this with REST API calls. So you don't even have to write a backend for this. I think it makes it pretty easy to start with IoT. Yeah, this is the Brew core, the brain of the project. And I mentioned we have a native mobile client, the Brew Mobile. It's written in Swift, it uses reactive Cocoa and communicates in WebSockets. It's written by Agnes, actually. She's sitting over there. Yeah, it makes it pretty easier to brew beer from the coffee house, for example. And this is my favorite fun module, Blue UI, because this is the web client, and it's written with React and Flux, and it's an isomorphic application. It's written in a Node style and uses the CommonJS module system. It's bundled with Webpack, but it could be Browserify as well. For example, it's available as NPM module. But what this isomorphic means, actually isomorphic is code sharing between different environments. So for example, your application is able to run on the server side, on the client side as well. But why is it good for me? Because in this case, you can have all the power of the different environments. For example, between the server and the client, you can have the power of the server rendering. So your application will be really crawlable for the search engines. It's good from the server point of view. But you can also support the legacy process with the server-side rendering. But because your application runs on the client as well, you can have all the power and speed of single-page applications. A single-page application, for example, Angular. Yeah, and how is it implemented in Brewfactory? After the server received the request from the client, we have this isomorphic application here, the React Flux application, and we create a new instance from this application. We load with the initial data, and after that we serialize the data and we render the DOM to the response and we send it to the client. So when our client receives the response, it will contain the serialized data and the render DOM as well. So when on the client we create a new instance from the same isomorphic application, the same React Flux application, what we use at the server side, you can load the data into the application. So it can continue from the point where the server left it. And because the DOM is already rendered on the server side, the client-side application will see that it's the same, so it won't render again. From this point, this application will act like a single-page application, so really like Angular application. But we don't have to wait the initial load of the single-page application, so it can be really big. And I really have only two slides left on the isomorphic JavaScript, so sorry, but this is my favorite topic. And about isomorphic challenges. One is the data fetching. I will talk on the next slides about this. This is an environment-specific problem. And another problem is initializing the application, because we have to do it both on the server and on the client side. It can be a hard challenge. And another one is when you are at the browser on the client, the environment is singleton. But on the server side, we handle different requests from different users, so we don't have to share data between them when we don't want it. And the Brewfactory problem, I mentioned it's an environment-specific problem because we should provide the same functionality on the same interface. But it will be really different in the background, because on the client side, the data fetching can be as AJAX request or WebSocket event, but on the server side, it will be a database call to the microservice request. So it will be really different. I would like to recommend you to talk here from Pete Hunt from the React.js conf. It's called Full Stack Flux. It's not really about isomorphic, but it's about how they want to solve this at Facebook. And now it's demo time. How does it look like Brewfactory? Okay, I have to find my cursor. This is the interface. You can see the temperature steps here. Now it's more Spark device in the background, so it's not a real device, but it's act like a real. So yeah, when we're heating, then the temperature increase, stuff like that. This is the PWM, what I mentioned. This is the actual output of the power. So it's always changing because we would like to keep the 45 degree. Yeah. But why is it interesting? I would like to show, okay, we also have some logs here, so you can check your previous beer. But I would like to show this isomorphic stuff to you. So let's see this chat, for example, or the designer. Let's disable JavaScript. No, it's fully server rendered, but it's still working. Of course, it's not responsive because there is no JavaScript, but it's SVG graph, so it's rendered on the server side. And because it can work without JavaScript, it's scrollable and it can support the legacy browsers as well. In this case, of course, the anchors actually JavaScript code didn't catch the links, so it will be really a request to the server. So it's still working. Of course, we don't have PWM data because we don't have WebSockets without JavaScript, but let's enable it. So when I enable, it's much faster because it's a single page application now. You can check here in the network panel that when I select another one, Brew, it really communicates in a pure data because it's a single page application.
Sure. What did you enable there?
The JavaScript support. I disabled earlier. So maybe it's, okay, maybe I should, no, I can zoom, but maybe here I can, if I remember right. Yes. So now when it's a single page application, it's, okay, no, it's disabled. So you can see it really communicates, it's a response from the server, it's HTML response, yeah, here as well. But when I have JavaScript, because it's a single page application, we don't load the templates again, we load only the pure data. Okay, back to the presentation. Actually, it was the last slide, I guess. Okay, so only if you like the project and the technologies, what we use, then please join and contribute. It would be really great. And thank you for your attention.